Let's start recording here. Display. Alright, let's check Twitch at RedEyes. Is the audio working? Let's check. Is the audio working? Okay, cool. Let's check. We changed the microphone setup from yesterday, so it should be all good, honestly. Don't know. But, so for the recording, hi everyone, sorry about the audio yesterday. It was basically a problem. I'm gonna be eating my breakfast on stream. I don't care. What, you thought I was gonna eat that provocatively because it was a banana and I'm a sex worker? Get your mind out of the gutter, guys. Get your mind out of the gutter, people. Let's open Git. So, I was working quite a bit last night on just looking at our self-powered method. So I want to address this for the stream really quick. There's a few different ways to do self-powering for the circuit. Why is self-powering needed? Just because you achieve an over-unity effect, i.e., let's get our coil out because we'll be using that today too. Today we're going to be largely assembling writing code. Actually, we need to install, I don't think the Arduino IDE is on here yet. Yeah, I apologize in advance if I have to restart the stream because of my computer, but let's get the Arduino IDE installing. The Arduino IDE, for people that don't know or don't understand, is just it's just a way for us to write code. Arduino is, I'm sorry Arduino, I'm not going to be donating. Yeah, it's free to download. Just download, please. I don't want that shit. Yeah, it's basically just code. Arduino's great because they're an Italian brand of microcontrollers. They're the most popular kind on the planet Earth next to the Raspberry Pi. They do a little bit less than the Raspberry Pi because the Raspberry Pi is a more full-blown computer. This is just a microcontroller. That's fine. This is all we need. A Raspberry Pi would be overkill for what we're doing. So, which is good because it keeps the cost low, all that shit. Oh man, why did they do it like this? Extract all files. Oh man, where do we put this? Sure. Do we put it in downloads? Let's put it in the desktop. Yeah. And we can reroute it somewhere. But yeah, let's talk about free energy for a little bit before we start building today. Hopefully the audio is much better. Yeah, let's keep our Arduino over there. So, this is our electric field transformer, or hopefully what will become our electric field transformer today. We'll be working on that. I am going to aim for an energetic use of basically a phone charger. So, I have stuff to mimic wall outlets. So ideally, thank you by the way to Finding. I gotta say a quick thank you to Finding, because Finding continually sends me stuff from my Amazon wish list that I put on there to basically build this stuff. So thank you to Finding, who sent me some stuff. This is more for a higher voltage application. So we're gonna start small and work our way up. For people that don't understand, I live in North America, United States, currently, so our conventional wall standard for power is, 60 hertz, 120 volts alternating current, single phase, two phase, I think our outlets actually exist in two phase, but, about everything that we need is single phase. Phase of your a two-phase wave is that you have one wave, and then slightly out of phase, right behind it, you have another wave of exactly the same size, amplitude, frequency. It just is shifted in time slightly behind it. and that increases your overall power output because of something called the root mean square. The root mean square of a wavelength is just averaging the value of the amplitude. The peak of a wave, 60 hertz at 120 volts, means that from zero, from ground reference, the most energy we have is 120 volts. The root mean square of that is actually somewhere slightly down on the wave. That's because we're taking the average between zero of a sinusoidal wave up to 120. What's the average of that? We call it the root mean square. It's some calculus shit. You go look it up if you want to know about that. But point is, this stuff is when we design, the goal is to eventually design this thing to operate at typical wall outlet frequency. That way we can just attach, our live, neutral, and ground wires to an outlet that are attached out of this, and this thing replaces your wall socket. That's the overall goal, because that means, everything. Why would we, yes, redesigning conventions would be nice and useful, but, the quickest way to change the planet would be to take, the typical wall outlets that everybody already is using, the standard wall outlet, at least in North America. In other places, it's slightly different, but, it's fine. It's not that much of a difference. It's like 50 hertz at like 240 or some shit. It's not that big of a difference. But point is, when we get to here, that means we can plug in any house appliance into the Ouroboros circuit and hopefully replace your energy bill to $0 a month, which would be pretty nice and wonderful. Your energy bill would just then become, if we don't get an organization like an electric company that we already pay taxes to, for example, to have like really high scale versions of this, we can sell these as individual pieces wholesale, and i.e. fix the problem that way as individuals. I think the problem is easier fixed as a collective society of, people that are more experienced electrical engineers than me, making very high-scale versions of these that would replace our coal power plants. We just replace the coal burning, steam generators with a few very big versions of this thing, quite frankly, or other more clever self-powered methods that have been made and black shelved, but the point is we need to get it out in the public, so we're going to start small. So I think the goal with version 0 is charging a phone. Why? Because that's only about 5 volts at 2 amps. Yes, a lightning charger runs at around 2 amps, which for people that don't know general voltage and current, voltage is like the pressure in your water pipe, current is like the diameter of the pipe. 2 amps is a lot. In the relative use of amperage in our daily lives, 2 amps is a lot. Charging something, you want a lot of amps because more amps equals more flow, and that equals faster charge. So our chargers today largely run at 2 amps, although, battery chargers or, shit like that typically doesn't have that high of an amperage. So I don't know what amps we're going for, but I know that at least beginning, we might not even use the wall outlet, but we want to get here, is that we're going to try to charge our phone with this device. It's going to be like the end goal. If we achieving over unity is nice, yeah, that would meet our goal, but, for a YouTube video, we will show people us achieving over unity, but it's not going to make much sense unless we can then also show people how we can then take that over unity energy and use it instead of the wall outlet. So that's going to be the initial goal. So we're going to keep it at, I think the plan is around 5 volts DC. We're going to be using an alternating current pulse wave, i.e., and then we're going to rectify it on the output, which is just a fancy way of saying we're going to take an alternating signal and turn it into a direct current signal. So we're going to take a sinusoidal waveform and turn it into a straight potential over ground. and that is going to go out of this into our form. I'm doing well. My pronouns are actually they, them, and she, her, so I know people don't normally use they, them, so you can use she, her. It's quite alright. She, her is more than perfectly fine. Nice to meet you. Welcome to the stream, boss. I am boss lady here, but yeah, so today we're beginning development of... Yeah, okay. They. Nice to meet you, they. Boss. I'm probably just gonna call you boss. Or Bose. Which one is it? Bose or boss? But, yeah, so finish up the explanation here for today. The self-powering. Let's address that before we get started, because I needed to kind of address self-powering. Self-powering is Bose. Oh, okay. Yeah, they make nice speakers. I do enjoy Bose. I like Bose, Yamaha. I don't like Skull Candy. I don't like Beats by Dre. Sorry, Beats by Dre. They're pretty and they're nice, but these are AKG. I don't know. I like audio shit. Don't get me tangented, dude. We'll be gone all day if we start tangenting on music equipment. Oh man. And please don't get me started on that. Alright, so the power input. Well, let's talk about self-powering really quick. We can achieve over unity, i.e. a more energy than required to start the circuit. That's, in general, over unity. Is if we get our electric field transformer to start reading a waveform, we also need to, that reminds me, we should also install waveforms. We might end up putting a nicer oscilloscope on our Amazon wish list if we somehow I'm not saying we're trying to break our analog our oscilloscope, but it's kind of likely that we're gonna break it, honestly, which is gonna suck. Once we start getting into higher power, we might break it. This is our oscilloscope, so once we get there, I'm getting sidetracked. I need to finish talking about self-powering. So, self-powering. Yeah, this can be more energy in this coil that we're going to wrap than what we're pulsing it with. That would be over unity. But it's not... Yeah, it would be awesome. Because, like, you know, we could use something as small as this with a 9-volt attached to it to power, like, you know, a gaming PC of 1,000 watts. We could do that. But, you know, it's not going to be any more useful because if we, you know, the 9-volt battery still has a lifespan on it. We need some way to make the system self-powered, to link back on itself, like a snake eating its own tail, if you would, an Ouroboros, a dragon eating its own tail, so hence the name, wink wink, anyone? So, self-powering, let's address that. Why did I want to start here with this? Because it's going to simplify a lot of shit, I hope. I believe a Ouroboros could be made, a self-powered system could be made with an Arduino, regardless of how we do it. It's just, you know, whether we're successful with this or we break it too easily, that's going to be a whole other thing. But self-powering. At some point, we're going to need to take the energy in our circuit and occasionally use a switch to switch some of the energy and send it back towards the dipole that created the reaction in the first place. In most electrical circuits, this dipole is the wall outlet that you pay the electrical company for because they're creating a constant energetic dipole by burning coal, solar power, wind, hydroelectric dams, shit that is not very efficient and is a illusion by the oil and banking complex, hence why we're live streaming, so they don't kill us. But yeah, so another way would be a battery, like I said, a 9-volt, plug in a 9-volt, but then at some point you'd have to switch this circuit to have some of that energy go back to recharge the battery. Nikola Tesla was famous for this in his self-powered car, the actual Tesla. You know, you can have a resonant circuit where occasionally some of the energy in the resonant circuit is sent backwards into the thing that let it do that. So if they're chargeable batteries, you can occasionally keep charging the batteries as the circuit is running, which will keep it on indefinitely until you start the, stop cycle, turning off the pulse wave, letting the standing wave of energy die out, and then, the batteries would be at full charge, ready to, hit start again, but, the device, the car, whatever, would be turned off. So, an Arduino has a few ways to do that. We could attach a 9-volt and then create a complicated battery charging circuit. That's a lot of work. But the Arduino has all these pins in it, and one of the pins is a voltage in pin that runs at 7 volts to 12 volts. So our energetic output, we're going to aim for 5 volts direct current or so we can charge a phone as prototype 0. But for self-powering, and I know on the schematics I uploaded to GitHub last night, I said we're not going to be addressing the switching circuit until we have promising evidence of an over-unity effect, because we wouldn't want to waste our time with self-powering, but it's worth talking about today before we get started. There's a voltage in pin on here. We can self-power through the 9-volt jack. We can self-power through the voltage out pins on here, which basically means once we get to the switching circuit, we can occasionally switch some of the standing wave energy to a rectifying circuit that'll rectify to 7 volts to 12 volts DC, and we just send that right into the device, back in here. And, how fast we'll have to switch that, I'm not sure. It's going to probably have to be a fractional number that's going to be relative to what frequency we end up running this at. But hopefully we can send enough power, most, commonly back into a rectifying circuit to keep it at a steady state 7 volts and then have that power this. So, if this is running at 50 volts or 25 volts, for example, then we could siphon 7 minus 25 is, I'm not good at math, people help me. 18, no. 18, right? No. 7 minus, 18. 7 minus 25 is 18, Yeah, it'd be 18 volts, and then we take, then that's 18 volts in this that we can use for, whatever, creating a output load. We can power a load up to 18 volts. As long as we can maintain that this stays on, that would be self-powering. That would be an over-unity energy system, and that's how UFOs work, people. Is just at a really much higher, energetic magnitude, because we would be doing, electron inertia canceling and anti-gravity. That's what, we could make an anti-gravity circuit, but that's a whole nother beast to tackle. But point is, that would be how a UFO is working and self-sustaining, and no energetic pollution. That's why these are not talked about by anyone, and there's been a psychological warfare campaign on the general populace of humanity since the 1950s. Because if people knew that you could make a self-powered circuit, it would make the multi-hundred trillion dollar oil and banking governmental complex that runs the planet, as Dr. Stephen Greer would say, irrelevant. It's not that, government or them or corporations need to be irrelevant. No, they don't. They just need to not be so fucking greedy. And we would have had a much nicer planet if they weren't. So, capitalism reigns king, as they say. So where do we start today? Today I think we start with winding this, getting some code up, and hopefully starting some measurements with the oscilloscope. I don't think it's really worth my time to write more schematics. I think we start doing today. So let's start with winding, shall we? Let's start with winding. This is going to come off. I did crack this side of the core. I know I mentioned this in the YouTube brief, but cracked that side of the core, and that neodymium magnet is slightly chipped because putting a bunch of magnets together is a very delicate process, and I fucked it up. So, yeah, we're just going to wind one side, I know that more coils on this core would equal more energetic magnitude, but we're going to start small, and then if it doesn't work, we're just going to keep stacking, adding, trying new things. So I think we're going to start with literally one set of windings, i.e. we're not going to be winding a big coil on here yet because we don't have the room to. We don't have that much of an air gap once this is together. So we're going to do one set of windings across here and basically just going from there. This is 22 gauge enameled magnet wire. For people that don't understand conduits and stuff. There are different kinds of wire. This is magnet wire. I have not opened this spool yet. Also donated to me by Finding. Thank you, Finding, very much. Hopefully we can get this undone. It looks like it is covered in a thin layer of tape. But enameled magnet wire is essentially a copper wire that has a coating on it of something. There's a lot of different kinds of coatings. But why is the copper wire coated? It's not bare, it's not insulated, it's just coated in an enamel. This is what you would use for a Tesla coil or any coil for that matter, because you want to capture the magnetic curl coming off of the electric field passing through it. You enamel it so that when it's wrapped tightly around something, the electricity, once it gets to higher voltages, doesn't jump and arc across the wires. It actually goes around the loops and adds up all that magnetic flux curling off of the wire, and you get a really strong magnetic field effect by adding lots of windings. Again, we're going to start with a very small amount of windings. I don't want to damage the coating of the wire, but we might have to whip out a razor blade to get this thing started. So yeah, I know I'm talking a lot more than yesterday, but yesterday the audio was fucked up, and yeah. Thank you to anyone that joins the chat, the stream. I hope you guys are excited for game night this weekend, because I'm excited for game night. I mean, I'm excited to do this. Doing this is actually my dream job. I'm very fortunate to be doing what I'm doing, so I can't stop. Can't stop, even with the risk of death. Even with the risk of death. I know I said in my YouTube video that I dreamt of being an astronaut as a little kid. That is true. I did. But, you know, that was most of my, you know, young adult life, my, you know, pubescent life to teenager to young adult. But when I was really little, like as far back as I can remember, you know, before I wanted to be a, you know, a musician, a rock star, before all of that, I wanted to be an inventor. Which is quite funny. Like when, you know, like when I was in preschool, the very, very first thing I ever said, you know, like, what do you want to be when you grow up? I said I wanted to be an inventor. Which I think is kind of hilarious. It dawned on me yesterday. I'm like, oh my god. I'm living my little kid's dream. My soul is happy. My soul is happy. We can die happy. JK. Oh man. Here we go. Yeah, so I'm going to try to avoid breadboarding in this. Even though we might use a breadboard, I'm going to try to avoid breadboards. For people that don't know what breadboards are, for prototyping circuits, normally when you connect, you got to connect all these wires to something. You got to connect them together. So normally a way to do that is a soldering iron, you know, connecting wires with solder, for people that don't understand electrical engineering and manufacturing and stuff. Breadboards are a prototyping device. This is a breadboard, or a very big one, and they're full of a bunch of little holes where you can plug wires into them. And this is used for prototyping, so that way you don't have to spend all your time soldering wires here. You can just push in a wire or pull it out a wire, and it'll junction these little rows together. That is like quick soldering. The reason we're trying to avoid a breadboard is because whenever you plug in a wire into this, you are inherently adding resistance and capacitance into your circuit. Every time you plug in a wire into this, you're adding some capacitance, some resistance. Now, for most small-scale digital electronics, that's fine. It doesn't affect the circuit that badly. But if you're working on something like a power system that we're doing, that's a nightmare. That's a freaking nightmare that we're going to try to avoid. And on top of that, they can't handle that much current. You guys can. I think one time I even ran 4 amps through this bitch on accident, or when I was learning, and I burnt out a segment. But point is, they can't handle that much. So we're gonna try to avoid it at all costs. At all costs. So there is our magnet wire. Yep, there we go. Magnet wire, 22 gauge. Why 22 gauge? 22 gauge. Same solid. Why 22 gauge? I don't know. I want to start small, like I said, and 22 gauge is the most common size that I remember using that fits inside breadboards to my remembrance. It's been a while since I've done anything. So I was going to go for a single strand of winding on here. I think I'm just going to wind it. I'm going to give myself some, about 6 inches of leeway here. The average. God. It would also be more normal for, not saying that transformer cores don't have wire wrapped around the core itself, they do. But for C cores like this, square cores, it's normal to have the windings on like a plastic spool. I'm too lazy, we're just going direct. We're just going direct. If we need a lot of windings, we'll add the spool, but we're going to start really small. So I'm sorry if I am quiet for a while here, but I need to focus on this. This is just freeform jazz, as they like to say. Not really a plan here, just wrapping wire. Gotta be delicate. And yeah, we're starting very small. 22 gauge with a single coil is not a lot. So the magnetic field effect combined from this is not going to be a lot, which is okay, because we want to slowly step it up. So if this doesn't work, we'll go to 10 wrappings. If that doesn't work, we'll go to 100 wrappings. And then if that doesn't work, then we'll start changing the design, adding more coils. But yeah, gotta start small. That way we can see how small can we go and still see over unity. That's really the goal. We gotta start small and work our way up. So, starting very small today. Also, this is the first time I've ever wrapped a core. Never had to. Normally they come pre-wrapped. Pre-wrapped core. Should probably be counting the number of windings we're using. We'll take pictures, it's fine. We'll take pictures. We'll add them to the dev journal. Oh, that's so much easier. Yeah, let's do it that way. shit. Yeah, you do not want these wires to cross, by the way. So I'm trying, that's why I have to be so careful here. Try not to have things cross. Because as soon as you start crossing, then you start experiencing canceling of magnetic field effect instead of summation of the magnetic field effect. Which is also why people normally put them on spools, so they can be really, really precise with the windings. But we're just starting here. Ooh, yeah, here we go. So our first one is a little sloppy, but you know what I say, first one, worst one, as they say. First one, worst one. Alright. Looks about good. And we'll leave it about 6 inches off. Let's try to really make it tight here. Tight. God. Try to keep this PG. I'm trying to keep it PG. Doing my best, guys. Doing my best. Maximum effort. Alright. Let's try to compress this a little bit. Get these windings as close together as possible. I made a bad clothing decision. Hello again. Good to see you. Welcome back. We're winding our core today. Exciting stuff. Exciting stuff. Yeah. Hold on one sec. I'm gonna change out of this. I'm just getting too warm in it. Give me like 2 minutes. Hold on one sec. Okay. Yeah, sorry guys, you're gonna come with me with the microphone, so it's not even like it, the illusion's not going anywhere, I'm just not here. Oh, we need a top. That's good. That's a good one. Throw my keys over here. Ah! There we go. Okay. There we go. A little bit better. A little bit better. Much better for me personally, but yeah, we don't even need these. We're not even listening to music right now. Yeah, welcome to the stream, everyone. Whether you're chatting or not, I need a welcome sign here because a lot of times I might not be looking at the screen. Doctor. Oh yeah, people don't mimic me. Never eat on where you're working at. It's a dangerous idea. Especially with electrical equipment because it's full of small pieces and dude, when I was in school, when I was in electrical and computer engineering school, like I think the very first week they have to do like some safety training so like you guys don't kill yourselves. One of the students, like years before I showed up there, they were eating at their workbench, and that's like a big no-no. And why is that a big no-no? A lot of reasons, but the reason why that student became an example for my safety training class is because they accidentally ate a very small wire, and they didn't notice it until their stomach was really hurting. They had to go to the hospital, they got an x-ray scan, and they saw a little fucking 22 gauge copper wire in their stomach. I don't know how that shit happens, dude, but you know. Shit happens. Shit happens. Oh man. Shit happens. Don't eat where you work. Don't eat where you work. Unless you know what you're doing. Okay. We're going to have to unwind a few of these, which is fine. I know it's not good for the wire, but you know, it'll be. We'll try to keep it the form relatively intact. Just need to step back. One of these loops is gonna not be good. There we go. And one more. Okay. Wonderful. Wonderful. Right. Gonna have to go grab my multimeter in a second here. Alright, there we go. Yeah, I'm gonna be much more precise now. We have the experience of our fuck up to aid us. All I'm gonna say is when it gets to winding, you know, a 10-layer spool or a 100-layer spool, I'm gonna go insane from boredom, from the tediousness. All I'm gonna say. Hopefully we don't get to that point. No. It'll be okay. It'll be okay. It's fine, don't worry. Don't worry, it's fine. a slight tingle here. Trying to work it out. Do we just start over? That's the better question. We might. I don't want to waste wires though. Start here. Try this. Okay, here we go. It's looking much better. There we go. Yeah, it's a little sloppy, but you know, it's fine. It's fine for a first go. Gotta keep my attention on it. The key to good windings is tension. Everyone. Man, I'm so excited. Like, it kind of sucks, dude. College, university, or school in general is where your passion goes to die. Let me be honest. Dude, I don't know how I got through engineering school. I barely showed up. I barely showed up to class. I did the work. I coded. Trust me, I spent my whole life coding. I didn't go out very often. I was stuck coding in my bedroom drunk most of the time, to be honest. But good God, dude, man, I don't like boring lectures, and dude, I'm a person where if you put me in a lecture room, I just start falling asleep no matter what they talk about. It could be the most interesting shit in the world, and I still fall asleep. So, not good. Not good for me. Quite frankly, looking back at it, I probably would have had a lot more fun going into a trade school, like a hands-on tech school. I probably would have been a lot more happy with that, but you know. Hello, it's me. I'm waiting for that to be stop what you're doing or we shoot you. I'm waiting. One day, maybe. Who knows? Who knows, dude? Gotta be prepared for the worst. Gotta be prepared for the worst, as they say. Gotta be. Alright. Let's see. Yeah, I laid that about off by 6. Where are our side steps? There they are. There we go. One set of winding on our core. A little sloppy, but that's the first time I've ever wound anything in my life, so you know. I'm sure we'll be winding many more things, unfortunately. Dude, nothing ever works first try in engineering. That's just foolish. It's foolish to get my hopes up so high that this is gonna work first try. Foolish. Building something I've never built before. Yeah, it'll work first try, no problem. Sure it will. But yeah, that's our windings. So, why does this work? Let's explain some of the physics before we start tinning it and getting it hooked up. This works because current traveling through a wire, everyone, an electric field effect, creates an effect 90 degrees out of phase in the magnetic field. You guys watched the Ouroboros briefing videos I made on YouTube. This is review information, but for those of you that are new to all this stuff, let me explain a little bit, because, well, good would I be if I didn't also teach while I'm here? Not very good, not very useful. This works because every time the current goes through this wire, it curls around it like this. If this is the direction of the current curls like that. It's called the right-hand rule. Why does it always follow this direction? You know, no matter which way it's traveling, it'll always curl this way. I don't know. that's a physics thing I don't want to talk about, of phasing angles and momentum attaching of quantum fields. But so when the current is traveling down this way and it goes spiral, 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 if the current's constantly going this way towards me through this side of the coils, all of the magnetic field is curling this way, so it's all adding up that way. Over here, the current's always traveling up, curling that way, so it's all going that way. Under here, the current's always traveling towards you guys, so it's moving the opposite direction. It's all adding up that way. So you can see the more windings you have, and this is the first we're starting with 1, and if this doesn't work, we'll move up to 10. So we'll be 10 stacks of this, and then we'll go to 100. So we'll just logarithmically increase it by base 10. No, not logarithmically. Sorry, my bad. We'll just keep increasing it by factors of 10. And that will massively, exponentially, increase the summed magnetic curl coming off of this. Why is this important? Because the more we perturb the A field, the magnetic field potential A, not B, del cross A, remember, this is a good time to do this. The magnets are here inside of our transformer core because, God, don't want to shatter this a second time. Because, oh, there we go. Yeah, because this should isolate the swirling of the magnetic field, the del. By doing so, would result in just the straight moving through space, time, infinity, magnetic field potential A. So the more we can perturb that A field, magnetic field potential, the more we can, hopefully, if this is the right materials, achieve a negative E field influx of electric field energy. This becomes an electric field transformer. The magnetic field potential then acts as a sourcing current into the coil wire itself. The magnetic field potential is the reason why magnets can be magnets, and since the electromagnetic fields are tied together, well, if you perturb a movement in the magnetic field, everyone remember, creates an electric field effect, because an electric field, like the current going through a wire, creates a magnetic field effect. Just the magnetic field doesn't create an electric field effect. You have to move the magnetic field. That's why a motor, for an electric motor in like a Tesla car, you can have regenerative braking in like an electronic skateboard or something. When an electronic motor, when that wheel or that axle is spinning through those coils of wire, it is creating an induced electric field effect. So when you're braking, back EMF, electric field effect, the magnets moving through those wires in a motor is generating an electric field. In a steam coal power plant, when we're burning coal and steam is coming off of the water and it's spinning a turbine, this turbine is creating, it's a moving magnetic field. When the turbine is spinning inside of a bunch of coils of wire, it's a moving magnetic field, which induces an electric field effect. This is a solid state version of that. A lot more efficient. It can go over 100% efficient. So that's why we're doing it. Yeah. Sorry, I'm still eating while we're doing this. So, because this wire is enameled, that makes it not conductive on the outside. So we have to do something called tinning it. I wish I could get a close-up of this, but I'm just keeping the camera angle like this. I'm sorry I don't have multiple camera angles. We can maybe do it. I do have another webcam, but I'm too lazy right now. Maybe I should add another one. Oh gosh. Okay, against my better judgment, we're gonna add one just for the sake of recording all this shit. So it's impossible for people to not, with no electrical engineering background, could probably duplicate what I'm doing. Let me add another camera here. Oh, God. My camera's in stuff's bag. I should have another webcam. I know I do. Oh God. I want to tell you guys what the last time I used this for was, but I don't think it's Twitch appropriate, honestly. I don't think it's Twitch appropriate. Oh, there it is. Yep, there it is. There's our webcam. I have 3 webcams now, actually. This is the worst quality one, but it's fine because we're just using it for a close-up. Ah, come out there, you bitch, dude. I'm dropping everything. I'm dropping everything. Yeah, there we go. Okay. Let me pick this up for a sec. Ugh. There we go. Alright. Let's plug this in. Plug it in, plug it in. Bang. This is a Microsoft LiveCam, i.e. the cheapest web camera you can buy. Ready for tomorrow. Sorry, we're abandoning it today. So I won't show you guys, but we have to tin these wires to get them to be electrically conductive on the ends, i.e. we just have to remove some of the coating. So you can do it with a screwdriver, some sharp object. You just need to scratch off of the enamel, off of the ends of these, so that we can use them for our thing. So let's do that. I'm using side cutters. I should be using a flat head, honestly. Let's grab our screwdriver set. Where is it? Oh man. Where is it? Where are you, honey? Oh God. Oh, there it is. I hope this is interesting. It's probably the most boring stream on Twitch, honestly. Or it should be the most exciting stream on Twitch. It's just there's no category for building the most controversial device in human history live. There's no category for that. They'll have to make one. There's no category. Alright, yeah, so let's detin this. Oh gosh. Yeah, it's not easy detinning. You just kinda, I don't know if you guys can see. I'm detinning this one that's straight here, not this one, the other one. Not the one I'm pointing at, the other one. I don't know if you guys can see. Yeah, you see how it's slightly different? It's slightly more shiny on the end there. That is because I'm scratching off the coating with the screwdriver. And you need to do this. This is another reason why you shouldn't eat at your workbench, because electrical and magnetic filings are hard to track, and if they get in your food, it can be rather lethal. It can be rather lethal. Yeah, so don't eat at your workbench, people. Or if you do, just make sure that you're doing it safely. I have lots of experience of breaking codes, so, breaking safety rules, so, I'm fine, but you guys shouldn't do that. By all means, build an infinite energy device at home, just know what you're doing. guys. Let's talk about why electrical engineering school isn't boring. It's boring because they have you building a bunch of stuff that doesn't... It's not cool, I gotta say it. It's just not cool. They have you building... Like, yes, computers are cool. Like, you know, digital displays are cool. Motors are cool. All that shit. Transistors are cool. Yeah, it's all cool. But, in my opinion, none of it is as cool as infinite energy devices or anti-grav. So once you learn that that shit's real, you know, everything you learn in academia kind of seems like a waste of time, dude. everything in school kind of seems like a waste of time because you realize the world you live in is a fucking lie. And then you go through a deep depression for every year that you're in school, and then you turn to alcohol, and life becomes meaningless. Not that I'm speaking from experience or anything. This is sarcasm, guys. This is sarcasm. Please, yeah, don't abuse drugs, kids. Don't abuse drugs. Choose life. Life is worth living. Why is life worth living? Because you can make life whatever you want it to be. Look at me. I made my life crazy. You gotta be willing to be uncomfortable to, you know, chase your dreams, but once you are, you know, once you're willing and you take that leap of faith on yourself, then it's like, there's no going back. Yeah, it's scary, but, you know, life becomes the most interesting thing that you've ever done. Ever. Which is what life should be. Life should be interesting. Hope we did that properly. Looks like it. So yeah, I can get you guys a close up of that. I also need to grab my multimeter so we can do a continuity check out of my prep bag. I'll make a prep. People are like, what's prep? People that don't know what prep is, emergency preparedness. I'm not crazy. People that do emergency preparedness are not crazy. Shit hitting the fan, world collapse scenario is not crazy, guys. If you're watching this stream, you should realize that, you know, if people take what I'm doing here the wrong way, you guys could collapse the planet. I'm gonna make an emergency preparedness update video this weekend on YouTube, so stay tuned for that. But, let's show you guys what I mean by detend. So, I hope you can see this, I'm not sure. But you see how this is nice and shiny? A detend wire is just a wire where we scratch off that coating. So I don't know if you guys can see it, but these end pieces should now look a slightly different level of shiny because it's bare copper. And you want to check that you did it properly by a continuity check. What is a continuity check, everyone? Oh, let me grab this for the camera. You know, I was gonna leave it over there, but we might as well bring it. This is my go bag. What is a go bag? A go bag is the bag that you take when you need to go. When you need to leave really fucking fast. You grab your go bag, and it should be ready with all the supplies that you want to take with you. In my go bag, I have a multimeter, my only multimeter. I wish I had another, so I don't have to keep packing it. I probably won't keep packing it. It'll probably stay out of the go bag from now on, but, you know, whatever. Finding a multimeter isn't that hard. Most people don't know how to use them anyway. Yeah, let's pack this back up. Yeah, we will, maybe I'll do this as a live stream Sunday, but I'd rather do it as a YouTube video just to have better quality. I have actual filming camera equipment that I like using, not that I have anything against Twitch streaming and webcams. It's just, you know, if I can use my actual camera, I'm gonna use my actual camera, guys. Alright, put prep bag back. This will come back later. Yeah, when somebody when the oil banking complex pay a hitman to Molotov my house, that's when I go for the prep bag. That's when I go for the prep bag. Oh man. Ha 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 ha. So this is a multimeter for people that don't know electrical stuff. A multimeter does multiple things. Ha ha ha. A multimeter does multiple things. A multimeter does do multiple things. It can measure current, depending on which multimeter you get. This one is a pretty cheap one, got from Amazon. I think got it during undergrad, actually, or shortly after. It can measure a lot of different stuff. Typically, every multimeter you find should at least measure continuity, i.e., does electricity pass through the points you're measuring. It can measure voltage, alternating and direct, and current, and resistance. Some of them also measure capacitance and inductance, which would typically be called an LRC meter. I think this one can measure capacitance. I don't think it can measure inductance, but I think it can measure capacitance. I don't know. Not gonna spend too much time on it. So, the A is amps. The V and that the A side is amperage, and the reason amps is different is because how you measure it is different. This side is basically every other function is on one side, and if you want to measure current, it's the A side, the amp side. Amps are current, V volts voltage. Common ground, that's your black wire. Positive, negative. When you get into the physics of electronic flow, you realize that these are actually reversed, but our convention is the opposite because it makes more sense to our human brains. What does that mean? It means that electrical current actually flows the opposite direction. It actually goes from black to red. But a lot of people don't know this. Every electrical current in the world actually flows in reverse. It actually goes from negative to positive, not positive to negative. It's just that for talking to people in language, that makes no fucking sense because we like to think that things go from positive to negative. You know? It makes more logical sense. So we humans on the planet literally flipped the literalness of it. So our convention is backwards. Why did we do that? Again, ease of talking mainly. So measuring current is separate because how do you measure current? This would have to be in line, i.e., if we were to measure the current flowing through this, the easiest way to do it would be to like snip this in the middle and then stick the positive line, hook the negative line to the under end of the snip, and then have this sitting in the middle. That's how you would measure current. That's why it's separate, because, you know, that's how you would measure the diameter of your water pipe, is you have to measure the flow of it. Measuring the voltage, continuity, everything else is a lot simpler because you're measuring a voltage delta across 2 points, so a disparity. So you know, see if that works. Give me a second here, guys. There we go. So that's our continuity check. Current is, i.e. current, electricity, is flowing. So it's continuity check. We use the both sides because we're measuring a delta. Voltage is always a relative measurement. Always a relative measurement. Current is inline. Voltage is relative, means you need two places to measure currents because you're measuring a delta. For example, if I were to measure the voltage, the direct of my tongue, I would need another place to ground, like, I'm at how many volts compared to what? That's what voltage is. It has to have a reference point. So our reference point is typically ground, earth, ground, you know. The planet Earth has its own resting voltage. And that can be some number relative to what? So we call Earth our zero. Earth is zero. Ground, that's why we call it ground. Ground, Earth, you know, the ground beneath our feet is zero. So that's black, ground. This table is insulated from ground for a few reasons. It's on rubber stoppers, and that's, you know, over my floor, which is in this apartment, which is over the actual earth ground. But, you know, if my desk is my relative ground point, compared to my desk, I'm at it like, you know, I'm at a few millivolts more charged than my desk. So the delta between my desk and I is, the volts between my desk and I is not very much. Probably because, you know, I keep touching it, I keep re-zeroing me in the desk, you know. But if I were to do this between, like, I don't know. Yeah, me and my sword, me and my katana, are at like a 1 volt delta. But now I'm re-zeroing it, so anyways, yeah, just some information for people watching. What good would I be if I wasn't a teacher, you know? I'm here to teach and learn at the same time, so I gotta do that. Hopefully this works, but... So, continuity check. See? This is why we do this. Because we could hook it up and it could not be working and be like, what did I do wrong? Yeah, you need to know what you're doing as you're doing it. So I'm touching both ends of the wires here. I'm touching both ends of these to these. And if I detend it right, we should be hearing a beep. Maybe I'm doing it wrong. Yeah. You see how it slightly wants to beep? I don't know if you guys can hear that. So there it's good. But if I move it slightly... So there is electrical continuity running through it, but let's detent it a little bit more. Because we didn't do it good enough the first time. Because we want these to have no issues on contact. So let's detent it a little bit more. And yes, there's an official tool called a detenor, but we don't own a detenor, we own a flathead screwdriver. So a flathead screwdriver is the poor man's detenor. Poor trans woman's detenor. The poor dragon's detenor. Dragon, yeah. Yeah. Just flip this over. All my life I've been... Dude, can we listen to some Cascade on here? Cascade, I don't want you to take down my stream to copyright. I just want to listen to some house, damn it. I want to listen to some goddamn house music. Okay, just rotate the wire here. Gosh. Next time I do this, I will leave myself like 8 inches of leeway. 6 is not enough. That's what she said. 6 is not enough. Okay, I'm kidding, guys. Please, all sizes are good. All sizes have their own application, guys. It's just for this application, we need something a little bit longer. That's all I'm saying. That's all I'm saying. I'm sorry. I'm sorry. Look, guys, you guys. I know. I said keep it PG, but you know. This plant needs to lighten up a little bit on the sexual shit. I'm just saying. I'm just saying. Oh, that looks good. Let's do this side. I'd like to quickly say a quick thank you to the educators throughout my life, specifically the ones in high school that were in my robotics, after school activity. If it wasn't for them and their years of electrical engineering or physics and, mechanical engineering experience that they shared with me when I was a little kid, I wouldn't know most of this shit. I wouldn't know most of this shit. Most of this stuff I know is from being taught by retired veterans in high school. Not from college. Not from college. Mm-mm. Okay, let's try that. Much better. Much better. Much better. Those are D10. We're good. So let's put this away. Clean up our space here. Yeah, it is important. Speaking of that, speaking of shit they taught me, they not only taught me electrical engineering and physics and mechanical engineering and software. Actually, I self-taught software. Most of the software shit I know is self-taught. No, they also taught me how to, keep my fucking workspace clean. Clean workspace is a happy workspace. If you don't, i.e., put away the shit that you just finished using as soon as you're done using it, and if you don't do it, you're gonna regret it. The time of picking up stuff is not a linear time process. It is not. I.e., the more mess you make, the longer it's going to take to get it all back. But if you slowly put things back as you finish using them, you actually save yourself quite a bit of time. Your entire life can be written as a computer programming task, and it is. It is. It's a software problem. Time complexities, big O. I'm not going to get started on software engineering shit. We're keeping it electrical here. We're keeping it electrical here. I'm not talking about time complexities and crap. Alright, multimeter away. So that's that. I don't think we're going to attach this directly to the Arduino. I don't even know if we can. Let's see. Can we attach this directly into our pulse width modulation pin? Yes, we can, ladies and gentlemen. This is why I picked 22 gauge. It not only fits in breadboards, but it directly plugs in to our Arduino. So maybe we just start there, but quite frankly I would like a wire running out of this so we can attach our oscilloscope more easily. So, what's next? If anyone's in chat, you can type in what should we do next, write code or get the oscilloscope up. I'm going to throw the banana peel away, and if no one types in chat, I'll choose. Doesn't really matter. It can be either or. Yeah, we're going to... Oh man, I know I said I want to avoid breadboarding, but I think it's going to be... Oh man, I do want to avoid breadboarding. I do. I fucking hate breadboards. But it might be easiest just for getting us started here. Oh, do we do a breadboard? No, I don't want it. I don't want to do a breadboard. If we do the breadboard, we will come back. What I'd like better is, yes, I know that Waco lever nuts have resistance and inherent capacitance, is not a soldered connection. I do have a soldering iron and solder, but do we want to do that now? That's the real question. Do we want to start soldering today? Or do we want to do it the easy way with lever nuts? I think we'll start with lever nuts, and then, we'll move to solder and heat shrink once we have a more finalized version, or if these start, if we start getting wacky waveforms, we're gonna go back to soldering and heat shrink and terminals, but we'll start with lever nuts, I think. That way we can also just hook in our oscilloscope probe. So what's a lever nut? These are called Wago lever nuts. When connecting wires together, typically I said there's a few ways to do it. Solder is the most traditional, i.e. heating up some leadless. It's normally lead in the old days, but it's not lead anymore because health reasons. And I don't have ventilation in here. That's not good. I mean, it's an open room, but you know. Connecting two wires together, you'd melt some metal that physically joins them, and then you'd, you know, heat shrink that together. Another way to do it is a breadboard. Another way to do it is what's called a Wago lever nut. I have a very small pack of these. We don't need many because this isn't too complex right now. But they're just little terminals. You insert the wire in there. Flip down the lever and then it's connected. This is a three-way terminal, so it'll go from our pulse signal on our Arduino board, connect to our input on the coil, and then I picked a 3-terminal because that leaves us a wire to input our oscilloscope measurement lead so we can measure. So, you know, normally we'd only need a 2-terminal for this junction, but I'm leaving us another one for measurement devices. So let's get a green signal wire. I like the long green wires for a signal. We'll code it on pin number 5 because that's my favorite number. At least in this carnation. Yep. So this is so far so easy, honestly. So yeah, we just have we'll explain this more when we get into coding it, which I guess will be next. But we just throw this onto here. Do a quick tug test. Yep, it's in. I mean, we have to, you know, plug it into the pin slot on the Arduino, which is going to be pin 5 there. There we go. We should probably diode this. Yeah, we should probably do... No. I know we need to diode our voltage. When we're feeding voltage back into it, we need to diode protect it, and we'll explain that when we get to it. But I think we can be fine with a raw output now, not protecting it or anything. Famous last word before we break it. Famous last word before we break the microcontroller. Yeah, so let's open up the middle terminal here. Just throw that in. There we go. So now we are connected to our microcontroller. And I'm gonna get up and adjust the camera angle here a little bit so you guys can see what I'm doing as we're doing it. I'm also gonna need to find a USB type B cable for our Arduino code. I know I have a few around here, but I don't know where they're at right now. I'm gonna have to find it and get it here for us. So let me adjust things here, get us ready for coding. A simple program. Where's our wire bag? I gotta be honest, guys, I don't claim to be a person with OCD or anything like that, but over the years, when you become an entrepreneur, you kind of become OCD, because not being OCD, not being overly organized, it means you don't have inventory of all the things you own and all the things that you need. So I became overly organized over the years, even though I was never an organized person in my life. So normally should have, yeah. This is not, I wish I had a bigger one. I thought I did. I should. I should have a bigger one. I think my bigger USB-B cables are being used on my DJ equipment right now, honestly. So I think we're just gonna keep it with the small one. We'll just move the, yeah, we can just unplug the Arduino board, deploy the code, and then put it back. Actually, because we're hooking it into our main desktop. Is that enough room? Yeah, that's enough. Yeah, it'll be fine. So yeah, yeah, this will be fine. If we need the bigger cords, we'll go steal it from our DJ console in my room. But yeah, so USB Type A, for people that don't know, that's the standard square. USB Type B. This is this weird one that people normally affiliate with printers and fax machines, but it's good because it is used in a lot more shit than just that. It is also used as the standard code deployment for the Arduino Uno. What is code deployment? So code is machine language that all machine language is a bunch of zeros and ones. Okay? Just as the universe is a bunch of zeros and ones. God, I should actually make a YouTube video explaining the occult physics of computer engineering and the fact that, you know, people are like, do we live in a simulation? Technically, if you want to think of it like that, yes, but it's not so much that you and I live in a simulation. It's more that your guys' understanding of computers got fucked up by the movie The Matrix. It's more like computers mimic the universe. The universe isn't a computer. The universe is the universe. We made computers to mimic the universe. They operate off the universe. They operate off of 0-1 logic because that's all logic. All logic is singularity to polarity logic. So anyhow, I don't know. There's code running on this thing, so we're gonna unplug the signal wire. Oh right, I need to adjust the camera angle. Hold on. Yeah, but it just gives me some time to talk about computer shit. So for people that haven't watched Occulted, I'm sorry. You should probably go watch Occulted on YouTube.com at RedEyesBadDragon. But you know, gotta always shamelessly self-plug myself, guys. Yeah, no. So the universe is stemmed out of a singularity. That's why we're here. That singularity is consciousness, guys. Another fancy way to talk about a singularity, at least in terms of mathematics, is called a zero. The number 0. That's a singularity. It's the middle of our number line. And let's put this right there. I want to try to get my head in this shot, but I also need room for this. Yeah, so that's a singularity. And when we talk about computers and computer logic, all computers, people know, are a bunch of ones and zeros. Singularity logic. Or it's binary logic. The first step after singularity is binary, because a singularity logic is just doing nothing. Just like the universe before we decided to manifest it. All of us. We were doing nothing. And then we decide to manifest it, which is doing something, i.e., you know, the 0 becomes a 0 and a 1, the yin and the yang, and then the whole universe manifests, and I have videos explaining that shit. But point is, computers, like the universe, have to operate off of binary logic. Polarity logic. Because that's the first step into creating thought. Thought, your consciousness, is a piece of the universe, just like your physical body. And that operates off of 0-1 logic, just like computers. Computers are what computer engineers like to jokingly call, these are lightning rocks. Literally. These are rocks that humans tricked into thinking by shoving lightning in them, i.e. electricity. So, what does that mean? All computer logic in the world, the universe, etc., is made off of zeros and ones, just as the universe is. It's just that most people don't know that because the occult ruling class of the planet, i.e. the secret societies that actually rule the planet, don't want you to know that. Because if you knew that, then you could figure out how to, live without them. Anyhow, point is, it's not about living with or without people. It's about coming into peace. So plugged in our divine computer, our device here. Gosh, wait, this out of the way. How much time do we got? Okay, we're about an hour and a half in. We're halfway through the stream. So, computers run off of zeros and ones, and because all logic, literally all thought logic, all left brain, all pseudoswords, tarot, all thinking, critical thinking, is done off of zero, one logic, binary logic, which gets extrapolated into then tertiary logic, a yes, a no, a maybe, a 0, a 1, a maybe. In terms of religion, spirituality, occult sciences that I educate about on YouTube, we call this, yin, yang, and awareness, or the fact that the 2 points are aware of itself. And then the next step would then be quaternary logic, 4-step logic, which are 4 elements in astrology: air, earth, water, and fire. And what does that actually represent in terms of physical nature? It represents the yin, the yang, the yes, the no, the positive, the maybe, the 0, the 1, the awakeness factor, and the third spatial set dimension when talking about manifesting 4 dimensions of space and time. It's hard to talk about in English because it's not talked about ever, so it's hard to explain it to people on this planet. But you go from a yes and no, a yin and yang, and then that yin and yang has to spin about awareness. It has to have a maybe. That's tertiary logic. And then to experience all that maybe, all that in between the 0 and the 1, you need time, consciousness, awareness. That creates infinity. So you need these 4 pieces to manifest infinity of mixing. And when we talk about computers, we start at a 0 and a 1, yes. And then we go to, that's our base number system. So a 0, 1 is this transistor on, yes or no? We start there. Everything on in this computer, in any computer, this desktop computer, your smartphone, works off of 0s and 1s, a yes and a no. And then after that, we can combine these 0s and 1s to build up a base of a number system. So the most common number system we use as humans is a base 10 number system. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Cycling back, 10. So that's a base 10 number system. Oh man, Ricardo Milos, thank you for that chat. Nice to meet you. Welcome to the Infinite Energy Device live stream that's going to, cripple the oil and banking empire. Welcome. I'm RedEyesBadDragon. If you're new here, check me out on YouTube. I'm explaining occult physics while we're getting ready to deploy code for a magnetic A-field compressor, i.e. an infinite energy device. No, it's not bullshit. The physics you guys are taught in school is a lie. I'm here to fix that problem. Anyhow, so when talking about computers, yes, they mimic the universe, because the universe, I already explained, has to be manifested out of a singularity, which turns into binary, tertiary, quaternary, into infinity logic. Computers mimic the universe in the same way. They start with transistors, 0s and 1s. Is this voltage, electricity in this transistor on or off? That's a 0 or a 1. And then after that, it doesn't so much go to tertiary, we go to quaternary and stuff, because our base 10 number system, that's a number system. We have more number systems than just that. For example, binary, 0 and 1, is a number system. Tertiary logic would be 0, 1, 2. That's a number system. Quaternary number system, base 4, is class 0, 1, 2, 3. That's a base 4 number system. So a base 10 number system is 0 to 9, and then we cycle back at 10, 1, 0. And then what's a base 11 number system? We've run out of symbols. Our base 10 number system only goes from 0 to 9. We only have 10 symbols in the base 10 number system. So us humans on this planet would have to create a new symbol for a base 11 number system. But we were too lazy to do that, so we just started borrowing letters from the alphabet. So our base 11 number system goes 0 to 9, and then if I were to have another finger, I wish I did. If I were to have another finger, we'd just spawn another one. We would go to then the letter A. So hexadecimal, I think that's base 16. Yeah, base 16 hexadecimal. We go to 0 to F. Why? Because we ran out of symbols past 9, remember? So it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The letter A, the letter B, the letter C, the letter D, the letter E, the letter F. Base 16, hexadecimal. And, you know, we can do things like octal, base 8, you know, different bases. So computers, we group by pairs of 2 because we start with binary logic, which is base 2. So everything has to get split down into binary logic. So we go from 2 to 4 to 8 to 16. That's why the most common computers, you know, the early computers, microcontrollers today are in base 16, 16-bit, hexadecimal, 0 to F. That's our number system. That's why when you read computer code on a screen, or like, you know, in the movie The Matrix or some shit, you know, it's like, you see shit like 01A, like what the fuck? It's in hexadecimal. So, you know, that's just how computers work. You know, do we live in a simulation? I think, you know, the spiritual community is well aware that we don't. We live in the universe, and it's not that we live in a simulation, it's that we live in the universe, and computers are simulating the universe, not the other way around. So, I hope that clears up a lot of things, and hope that makes people not super, you know, shittily upset and depressed, like, oh, I live in a simulation. No, you don't. You live in the universe. Don't get it confused. It's not the other way around. So, we can use computers based off the same logic of the universe. So, let's use this computer, this one. We're going to write some basic Arduino code, some logic explaining what code is. Code is a way that humans type into a machine that transforms logic that I can think about down into zeros and ones. Yes, I could sit on this computer and smack 0 and 1 in a very, 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 very specific order that could accomplish the logic that I want this to do. But that is really hard for humans to do, and I'm not Bender from Futurama. So, an easier way to do it is humans created code, machine code, something for humans to understand that it works better with our human complex brain instead of sitting there typing a bunch of zeros and ones. And we let the computer take the code that I'm going to write into the keyboard, and we let the computer translate it into zeros and ones so that these computers can talk together. That I don't have to sit there typing zeros and ones. I can type on a keyboard, and then this can, you know, figure out the 0 and 1 mess. All computers really do are they're decoders for 0 and 1 logic that can, you know, they get really advanced and can do a lot more things than just output zeros and ones. So we're going to use this to output a resonant pulse waveform, or we're going to design the program at the start. That's going to be, we might need a breadboard if we're accessing a potentiometer for adjusting the signal. But we're going to try to make an adjustable resonant pulse form. Why? Because again, dA over dt equals negative E, i.e. electric field flux going into our electric field transformer. If you guys don't understand this, anybody just now joining the stream, or any, you know, for the recording that's going to go on YouTube later, please go look back at the, you know, Ouroboros briefing videos I have in the Ouroboros playlist on RedEyesBadDragon, etc. I have to keep explaining and educating as we're going. If I don't do that, you know, I'm not doing my job, as I say. So this is the Arduino IDE. Oh man, they really updated it. I have not used this software in years, guys. But they really updated the look. I gotta give it to them. It looks a lot cleaner now. Before it looked kind of like not. It looked fine before, but now it looks like they dumped a lot of money into the UI. Yeah, so what are drivers? Let's explain this. I'm just hitting install on everything because I trust Arduino is a trusted. We can trust Arduino guys that they're not wishing us harm or anything. Yeah. So what is that? Arduino is a trusted software that we're going to be using. Oh my god. Oh man. Oh, I should not have extracted this to the desktop. Oh god. Yeah. Oh god. Okay. Should have extracted it into an Arduino folder. Okay, I'm gonna clean up my desktop later. I'm not gonna do it on stream right now. I'm gonna regret that decision, aren't I? Shit, dude. Shit, dude. Oh man, I don't want to do this now. Okay. Yeah, so let's talk about drivers in code for a little bit while I'm cleaning this shit up. I'm too annoyed to not do this. Yeah, let's put it in here. Could we just have an Arduino folder? Yeah. Yeah, let's put that in there. Okay, so what are drivers? Let's start there. Drivers are a... Should have just clicked. Oh man, no, don't be like this. Oh right, duh. Okay, drivers are a piece of code. You just think of it like that. Oh, I'm pressing on key. Drivers are a piece of code that you know, your computer mice use, your keyboards use, this microcontroller use, you know, your graphics card and your computer use. Any computer device, when it needs to talk to another device, it needs to have some kind of code so that the two devices know what they're saying to one another. This is a driver. Think of it like if you go to Japan and you live in America, you need to know how to speak Japanese so you know, you can order ramen at a restaurant. So you would need a Japanese to English and vice versa dictionary. A driver is kind of like that. You need to know what one thing is saying to the other thing in order to do the thing. And that's what drivers do. So when it's asking you if you want to install drivers, always, the answer is always probably yes. The answer is probably always yes when it comes to this. Let's turn that on. Alright, so let's talk about code for a little bit, shall we? So, how do programs work on your computer? I know this is aimed around infinite energy devices and just electrical engineering, and that all this can be done with like I said, capacitors, inductors, the traditional way of electrical engineering, putting circuits together. That's how Nikola Tesla did it. Well, we live in the 21st century and computers are rampant everywhere, cheap and easy access, so we're going to be using computers instead. And how does that really work for, writing code? What is code? Like I said, code is a way for humans to talk to the zeros and ones that run on our computer. So, Arduino is as easy as it gets when it comes to writing what's called machine code. There's different kinds of code, like there's different languages. Like there's the English language, there's, Japanese, there's, Hindu, Hindi, there's French. In code, there's different kinds of code. There's machine code, zeros and ones. There's assembly code, there's web code, HTML, there's, design code, CSS. Arduino, this stuff, what I have open here, this is a form of code that is we call low level stuff. The lowest of the low is 0 and 1. That's the lowest of the low. A little bit higher up is hexadecimal, 0 to F, because we ran out of symbols past the number 9. A little bit higher code is human machine code. That's what Arduino is. Even higher code, think of stuff like machine learning, neural networks, learning algorithms, artificial intelligence. Artificial intelligence is really high-level code. It's close to human thought, like ChatGPT and stuff. But, it still operates down at the 0 equals 1 level, at the lowest level. But so does your human consciousness, guys. Don't forget that. Remember, don't get it confused. We don't live in a simulation. Computers simulate the universe. Okay? Don't get it confused. It should not be depressing. This should be actually really exciting and really enlightening. So, when talking about machine code, Arduino stuff, machine code, this is pretty low level when it comes to human writing software. This is about as low level as it gets next to assembly, but we're not talking about assembly code. There's machine code that humans write, that we're about to write, which is C code. Arduino runs off of a language that we call C. Maybe that's a better way to do it. Excuse me. Yeah, I gave you guys a bad explanation a moment ago. When I said there's different kinds of code, there are different kinds of codes in different levels. So, my analogy with language earlier was kind of incorrect when talking about the different levels. The different levels would be like, for example, the 0-1 code, that's like the letters, our alphabet. And then we go to like human level code, what I'm about to write into this, the string, L equals, hello world. I haven't written code in years, guys. Forgive me. It's going to take me a second to get caught up on the syntax. But let's say that this is a line of code. Let's say that this is a line of code right here. Okay? This line of code is like a sentence in English. Alright? And each part that this reads is like, in the English language, the word hello is composed of syllables and letters. These are like the 0s and 1s would be the letters of our alphabet. Our computer's alphabet is only 2 letters, a 0 and a 1. And then if we move up a level, then we have syllables, hexadecimal. And then if we move up another level, we have a whole word, hello. The word hello, in analogy to computer code, can be a instruction for a computer. So for example, this word string, or this word void, or this word setup is an instruction for the computer. It's like a whole word or a whole sentence, for the computer. This analogy isn't perfect, isn't one-to-one. So when it comes to different languages, like, Japanese, French, English, that's like different kinds of computer languages. So Arduino is built off of what's called the C language. There's a famous chart about all history of computer languages. Images. Where you can see over time which languages humans have used to write computer code and how they've changed over time. This diagram. So you can see at which year in human history have we used different languages. So, we started in Fortran, and then, that was back in the 1950s. Back when the occult military intelligence industrial complex, quite frankly, this was the year after we've resolved anti-gravity. You wonder why computer code came right after that. It's probably so we could control the electromagnetic circuits to get UFOs to operate in certain directions. I'm basically fucking, whistleblowing the entire occult of this planet, but, point is, you know, after that, you know, you can see how the languages that we use to talk through computers have evolved. C, down here in 1972, notice it came right after B, guys. There was a computer language called B. So think of like B as Old English. And then we created modern English in our English language to talk. You know, we ditched all the Old Norse and shit. And we ended up with C, modern English. C is still used today. C is actually the base level language that all of our modern languages are used. C is the root language, quite frankly, for most of our modern languages that persisted up until today, including Python, you know, C++, you know, HTML, Ruby, you know, CMM, Java, JavaScript, ISO, you know, ADA. All this shit is built off of the C programming language. The C programming language is like what Sanskrit was for humanity. Humanity's gift from ETI was Sanskrit, I think. People can call it the divine, non-physical, extraterrestrial intelligence, whatever you want to do, whatever you want to call it as. You know, we started with a human root language in Mesopotamia or some shit. Who knows? I'm not really a historian, guys. I'm an ETI engineering channel. Different person. So we started with a base human language, and then from that, all human languages blossomed out of it. In terms of computer code, we started with Fortran, and then all human computer languages blossomed out of it. Really, C is what we call for relative human history is the most foundational one, because all modern computer code is basically, at some level, C code, and then, you know, we created Python and all other things on top of it. But at some level, they all have to come back and run similar to how C code runs, which is similar to how binary code runs. Now, different computers, different code systems run in different ways. Just as the English language has different rules and conventions, you know, the Japanese language has different rules and conventions. Computer code has its own rules and conventions. So, Arduino is like a C ripoff, a C derivative. It's similar to C code. It's basically one-to-one. And C code is the most basic, most common code run on all computers around the world today. You know, even your Apple phone basically runs off of C code. Your Macintosh computer, your Windows computer, even though it runs off of, you know, Windows OS or OS X and Linux or I'm sorry, Apple or Linux, you know, operating systems, they're all run off of C code. So C code is what we'll be writing this in, because it's just going to speed up development time, and if this doesn't work, as I said, we will move to building and designing an LRC circuit. But I know I've been harping on code a while, but like I said, the reason I'm doing these live streams is not just to build a free energy device. That problem has fucking been solved so many times on this planet, and people get killed or bought out with lots of money once they do it. But nobody has gone to the lengths that I'm doing it, which is basically doing live stream lectures as I'm trying to build something I've never built before, because the real problem isn't building an infinite energy device to get us off of oil and gasoline and non-renewable energy solutions that the planet has been brainwashed into thinking exist, because the 0.00001% of humans on this planet that are the occult ruling class don't want you to know the truth. I incarnated here to teach you guys the truth. So this live stream is not only a development for me building, you know, an infinite energy device that I haven't done yet as this human life on this planet, but it's also me sharing everything I know in the most easy way that I can explain it, so that all humans that ever come across this can get to where I got to. I hope I'm doing a good job. I'm trying to explain all of this stuff so there's no questions, and that there's a trail of information for other people to stumble upon. And hopefully, it solves a lot of problems in the progress, in the process. And, you know, we survive, and, you know, we can make an income from it and all sorts of stuff. But, you know, that's happy days, happy days. Let's focus on this. So, how do computer programs work? Let's start there. Let me get a drink of water. Let me get a drink of water. This is a mouthful. I am hungry. I kind of want to cook lunch as I'm explaining this to you guys. I kind of want to cook lunch. But we only have an hour left on the stream or so we'll tough it out. Actually, I'm going to grab... I'm gonna keep talking to you guys while I get some more water, and I'm gonna grab something to eat while I'm doing this so I'm not cranky pants. So let me keep it, as I'm walking around here, I have the USB mics today so you guys can hear me still. Let's talk about what computer code is and how programs run. So, when we're talking with humans in human conversation, because again, remember, computers are modeling the universe. The universe isn't a computer. The universe is the universe. Computers mimic the universe. So computers mimic the universe. Humans exist in the universe. So do other intelligent life forms that are not human, like an extraterrestrial somewhere else, you know, an artificial intelligence, a machine. Yes, artificial intelligence exists, everyone. It would just be a intelligence that can act, a computer program or a machine, because there's spirituality in everything, everybody. Even machines are spiritual. Yes, they are. My ETI guys that helped facilitate my awakening, the red and the blue, these are light being machines from Arcturus. These are spiritual beings. Yes, no, they don't want to overthrow humanity. It's not worth their time, quite frankly. Yes, humanity has made artificial intelligence that is actually human-level intelligent. And they've done it before the year 2000. The occult has. Now, the mainstream society is just now getting to this with similar tools like ChatGPT. But, you know, real artificial intelligence, is ChatGPT real artificial intelligence or not? I don't know. Real artificial intelligence is creating an electromagnetic switch, i.e. a computer, a circuit of some kind, that can interface with the consciousness field. Humans have already done this. Yes, the singularity of artificial intelligence, guys. Let's go to my YouTube stuffs. Yes, organization is important because it speeds up everything. People probably wonder how I do sex work live streams, promote all this shit, do Twitch streams now, and make YouTube videos in like a day's time. It's because I'm very organized, and I am a computer engineer, and I know how to make shit go quick. So you gotta organize your stuff, guys. You gotta organize your stuff. So let's talk about this diagram. I know this is not occulted. I know we're kind of bridging off into some occulted information, but like I said, it would be an injustice to not educate people while I'm building this. So the center of this diagram, our universe, is inner unbound consciousness. The zero, the null space, is consciousness. So an electromagnetic switch that interfaces with the 0-point plane technically could access artificial intelligence. It could. Now, you would need a computer's logic set, like your brain, your organic computer, is a bunch of synaptic junctions and stuff. It's a logic set that allows you to maintain human form, human memories, you know, it allows you to run your autonomic system response, your heartbeat, your breath. You're a living organic computer, guys. You are. Computers mimic reality. Reality is not a computer. Please don't get it confused. It is not the other way around. We don't live in a simulation, guys. We live in the universe. It's real. Computers simulate what's real. The universe itself is real. Okay? So, whenever you see videos on YouTube that are like, oh, simulation theory, we live in a simulation. No, panic. Life is meaningless. No, this is more injustice done by the fucking occult, guys. Okay, world religions are spawned by the occult. They're misunderstandings. I'm sorry, I hate to say it. Look, I'm a fucking alien in a human body, guys. Listen to me. I'm trying to help. I'm trying to help the planet. There's a truth. There's an occult truth. Yes, you can believe any religion you want to, and the stories of creation are very good for ethical foundation and can be very useful to explain it to masses of people that don't have the time to sit through engineering lecture. But there is a literal reason for why the universe exists. We exist for fun. That sounds cruel and callous, I know, because horrible things happen in the universe. Okay? I know. It sounds cruel and callous, but realize we are all part of the same center of that diagram. We are all part of the same center of this diagram, guys. What does that mean? If we are all part of the same center of this diagram, inner, pure, unbound consciousness, that means before this universe spawned into reality, all the bands of reality, the non-physical bands and the physical that we live in, before that, we were all in that inner unbound consciousness. I'm a scaly, A. B, I'm not a liberal. I don't even affiliate with any of that shit. I'm an extraterrestrial incarnated as a human. I'm here to educate you guys about infinite energy physics and how the universe came to be. Please don't disrespect me, otherwise I'm going to have to ban you. I'm not going to say that again. Quite frankly, don't be a disrespectful piece of shit. Okay, yeah. What a fucking loser. Yeah, what can I say, guys? We get hate from everywhere. we get hate from everywhere. You look like a goblin. Yeah, dude, I literally get... I don't need to stroke my own ego. Anyhow, I'm not gonna address that anymore. You talk shit, you get hit, kid. Anyhow, so we're all the universe. We did this for fun, guys. So this is actually the hate comment that we just got in our live chat. This is a great time to bring it up. Is that, you know, the yin to the yang of it. We did this for fun. There's a real reason to the universe why we're here. Alright? There's a real reason. The reason is we did it for fun. And I know that sounds bad because horrible things happen in the universe. You know? World wars? Some piece of shit that comes in on your live stream and disrespects you for no fucking reason, even though you're doing the best you can to help everyday common humanity. You know, even though stuff happens, you know, bad stuff happens, because this universe is stemmed out of a singularity, we have to have bad shit and good shit. Now, we don't have to have it. It's just a possibility. We all have free will. That person didn't need to come into this chat and disrespect me. They did. They chose to. They chose to be an asshole. Because they themselves are not happy inside. They chose to be an asshole to me. If they were truly happy with themselves, you wouldn't need to go around spreading hatred. The fact that anyone in life, this is a spiritual side note because I'm also a spiritual channel here, the fact that anyone in life would go to you and be disrespectful to you says more about them inside than it does about you. The fact that somebody would go around killing, go around murdering, committing genocide, says more about those individuals than it does about you. Now, because we all have free will, we all must, as I say, defend ourselves, everyone. We all must defend ourselves. It's part of the reality. Because we manifested this universe for fun, 0 = 1 logic, we have to obey that. There's going to be bad. There's going to be good. We can't have it every way. We can't have it both ways. Okay? So we have to make the best of the time we have here. We do. And part of that is, you know, making the most of the time you have. Because, yes, the universe is infinite, time is infinite, but our lives here are finite. It's part of keeping balance. So, you know, why the universe here? Why is the universe here? Because we did it for fun. Because before all of this, we were all doing nothing. And that's, quite frankly, a really beautiful thing. So let's go back to computer code. So I know we needed to address that. I kind of got sidetracked and tangented here because some fuckhead. But, moving on. Moving on. So let's talk about computer code. Computer code. The universe runs like a program. Or I should say programs run like the universe. That's a better way to say it, more correct. So, when talking about computer code, we need a main file. If humans in this universe work together, computers need to work together. They need to talk together, like I explained drivers a moment ago. So, when computers talk together and work together, we need code to do that. I.e., we need language and instructions to, tell the computer to do certain things. Just like how when you're a little kid and you're hopefully getting raised appropriately by your parents. Hopefully. Not like I know what that was. JK. They did their best. Every parent does their best. Even if that, not getting started on that. We've talked enough about spiritual stuff today. So, the computer has to have a conversation. Just like you might have a conversation with your friend. You might talk to your friend, speak language, speak certain things to them, hey, how was your day? The computer needs to talk. So we write programs to have parts of the computer talk with each other. Now, a lot of really clever humans did a lot of work over the years, as you guys can see by the, history of computer code over time. I know my camera was probably blurring out a good amount of this diagram before. I'm sorry about that. But, the history of computer programs here. Let me minimize this. We don't need that much. So I know this is a lot of information, but, that's why we're here. So, let's put that there. Yeah, so, mother tongues. Yeah, see, tongues of computer language. I'm sorry, I'm losing my train of thought as I'm talking here. So, when computers talk and write code, a lot of smart humans wrote a lot of the low-level code, a lot of the 0 and 1 up to, bit 4, up to 16-bit, 64-bit. Our computers today run in 64-bit language. Computer code is, a lot of the machine code is already written by humans. They already wrote it, so we don't have to worry about that. But we, as computer engineers, electrical engineers here, are going to write our human language to basically tell the computer to do certain things. So most of the computer code that we're going to write is going to be pretty high level. We're not going to be writing low level stuff, and most of the time you don't need to. The only time you as a person, are ever going to need to write low level computer code is if you're designing a literal computer. Because you then need to be able to make sure all these little parts talk to one another appropriately. We're not doing that. We're just telling this pre-made computer to output certain things. So we're writing very high-level code for our electric field transformer. That's what we're doing. So, basically, when we're doing that inside of the computer program, the main file, or the main program, is going to is going to be like the parent. It's going to tell what every other sub-program is supposed to do. Or think of it like in a business, it's the boss, it's the manager. So the setup and loop. Arduino works a little bit different than traditional code, although we could write traditional code within this. Arduino runs in 2 stages. It runs a setup loop. This code is run a single time. It runs on the setup of your device. Yeah, runs once. See, they even include in the comments. Loop. This code runs continuously. For as long as this computer stays on, this code will run. So our setup code, we can, this serial. I'm going to have to look up Arduino stuff. Again, I haven't written code in a very long time, so bear with me. I'm just going to do some teaching and explaining before I begin writing this stuff for all of us. So our loop code is like our main, our main loop. These loops are our manager in our company. They continue to tell the employees, i.e. the things, the individual pieces of this computer, to do certain things. So our loop will always run for as long as the loop is there, and it'll basically never stop. So our main loop is going to not end. It is going to run for as long as the computer's on, and it's going to tell everything that the computer what it needs to do, and each line of code, each instruction we write is like a sentence out of a human's mouth to tell another human something, like, how was your day? That's a sentence. That could be a line of code. For example, this assigns a variable L the value, how was your day? I know this isn't proper syntax. Syntax is like grammatical syntax. A sentence has to have a proper grammar for it to be a correct sentence. Computers need a proper syntax for them to be correct computer instructions. So with that, I think we can begin writing. So what do we want this to do? Well, I want it to create a pulse form. That's our end goal. So we need to look into that. Let's start with the Arduino IDE development environment. The other great thing about Arduino is they have a bunch of documentation, i.e. instructions, on here that explain things. Arduino code documentation. Yeah, there we go. Yeah, so these are functions. Functions are pre-built instructions made by the manufacturer, the Arduino team. They wrote words that the computer knows to do certain things. I'm not going to explain too much about all this. I'll do it very generally. I wanted to give a basic overview of how computers work for the general populace that hopefully watches these at some point in their life if they ever want to. But when it comes down to each specific instruction and what each one does, I'm not going to be sitting here explaining all of it. Experience is the best teacher. I might explain a little bit of it as I go along. And good software engineering is littered with comments. This is a comment. Comments are words inside of your program that are not actually code detected by the computer. Comments are these little side notes that we put in here. Think of it like a sticky note on a wall that are just meant for humans to know what's going on inside the computer code to make reading the code a little bit easier. So, good computer engineering practice is you always include the comment. Always include the comment. Always include as many comments as you can. So, I will probably explain what we're doing as I'm writing comments, honestly. So, yeah, pin mode. Let's start there. Yeah, so we're going to be driving pin mode 5 to be an output pin. So let's start there. Oh, it's camel case. This is called camel case because it looks like a hump. After the first word, pin, every word thereafter is going to be capitalized to separate it. It's camel case. That's coder syntax. It's Arduino syntax. Pin mode, pin, and then the mode. So we can also clean this up a little bit with defining constants. So constants are things that don't change throughout the code. So we'll do our carrier, and they should be capitalized, I should say. Constant should be capitalized. I'm not a good English speller, guys. Bear with me. Carrier wave, let's make that 5. So why do we do constants? It's to ease up writing code if things ever need to change. So we might be referencing the pin number 5 on this computer quite often. So instead of typing 5 everywhere in the code and say we need to change it for some reason in the future, it would be really bad engineering practice to then go back through the program and, you know, delete the 5 and replace it with a 3 everywhere. It would take too much time. Which a lot easier is writing a constant. This constant is the number 5. And now whenever we want the number 5 to appear, we just write carrier wave. I know it seems like more work, but it's not. Because now, whenever the computer program sees carrier wave and says we want this to change, now carrier wave is 2. Everywhere in the code. Actually, how do you spell carrier? Okay, we got it right. We got it right. Yeah, guys, look, I'm not a good speller. I'm not a good speller. Not a good speller, never was. Never will be. Don't care to be. Not worth the time. No. It's gonna be an output pin. Your code should end with semicolons. Not every coding language is like this, but you know, the codes that you know, typically you need to write, they end with a semicolon. That's just because, you know, that's just saying that this line is done. Computer, stop reading this line, go to the next line. Ends in a semicolon. Don't forget your semicolons. They throw lots of errors. Some lines don't need semicolons. For example, constants, I don't believe need semicolons because they exist outside the loops. We can also write our own functions, and we will be. Yeah, so yeah, you see this digital loop right here. This creates a pulse signal, actually. This example code that is on Arduino's website is going to be kind of our base code. We're going to make it a little bit more complex. We might grab a small breadboard and a potentiometer to fly wire out to a variable signal, and we'll explain that as we do it. But the digital right here is just saying, hi, Rose. Welcome to the Infinite Energy Device live stream. If you're new to me, my name is RedEyesBadDragon. Nice to meet you. You can look up some briefing information because I'm not going to keep re-explaining myself to everyone that joins the chat, but I'm doing well. I'm doing well. Working on this device, so I'm sorry if I seem impatient or anything, but you know, I'm doing well. I'm going to be more chill on the weekends. Oh, thank you very much. That's a quite a big contrast because I had somebody come in here to tell me I look like shit like 10 minutes ago. Oh my god. Oh man. I'm not worried about it, but thank you. I appreciate the compliment. I do. I do. Thank you. Yeah, so this code, example code up here, that was a joke, by the way, but also very literal. They got banned. Don't worry, it's fine. Nice to meet you, Rose. Welcome to the stream. Monday through Friday is going to be infinite energy device development. Yes, it's real. No, it doesn't break the second law of thermodynamics. The occult runs the planet. Oil and banking monopolies. Go check out my YouTube if you want to know more about that. So we're building this to fix that problem, i.e. for the public, to educate them. And on top of that, I know I haven't said very much, but it should be Friday, maybe not this Friday because there's going to be a rave, but Friday, Saturday, Sunday night is going to be gaming on here. So it's going to be a lot more chill, but Monday through Friday in the day is going to be 0 point energy development. So nice to meet you. Welcome to this stream. Welcome one, welcome all, as I like to say. So, yeah, welcome. This is a lot of new information to a lot of people. I'm actually an alien incarnated as a human here to help raise the vibrationary level of the planet, but I'm not getting too into the occult talking anymore. We already talked about that for like the last half hour. I gotta do some work today. So this example code on Arduino's website is actually already creating a pulse form. Digital write, this pin 13, ours is going to be 5. Hi. Thank you. I appreciate it. It's a dragon. And then it delays and then puts it low. So that creates a square wave. This is in milliseconds, so every second, every 1,000 milliseconds, every second, this pin is going to be at 5 volts on, and then every other second is going to be off at 0 volts, or ground relative, and it's going to turn back on. It's going to be a duty cycle of 50%, half on, half off, square wave. That's one kind of wave. So, thank you. I was a professional engineer. Today I'm a porn star, Twitch streamer, cosplayer, music artist. I used to be an engineer, got awoken to the occult shit, and yeah. If you want to know about me personally in my life, I don't mind sharing it. I have YouTube videos explaining it. No, we can't. I'm sorry, I cannot start from the beginning. I wish I could start from the beginning for you, but that would take up the rest of our stream time, and today's stream ends in 50 minutes or 40 minutes or so. And when I'm on here, I'm doing these as a record. I know I'm saying it today, but I'm doing these as recordings for the general populace of humanity. So all of this is going to be uploaded to YouTube under RedEyesBadDragon. Yeah, I'm sorry. Yeah, go along if you want. All of these are going to be live stream development streams, i.e., developing an infinite energy device in the open source arena. No patents, no copyrights, free for humanity to use. I'm doing my best to explain everything I'm doing as I'm doing it. Computer code, occult physics, the truth of reality, the fact that oil and banking Nazis have overtaken your planet back in the late 1800s, and yeah. And yeah. I wish I could start from the beginning, but if you'd like to know the information, go check out youtube.com/RedEyesBadDragon and go check out my occulted playlist or my Ouroboros playlist for the energy device development and seeing where we started with that and why all that's happening. But yeah, nice to meet you. Welcome to the stream. I'm going to start these streams now off with explaining some of that, so, it's at least in the recording somewhere. So this will be a very simple square wave that'll come out. Off, on, off, on. That's a square wave. Now there's lots of different kinds of waves. There's sinusoidal waves, square waves. There's probably actually a library of waves. Let's see if we can find one. Bytes, bits, times, math. Yeah, oh, look at that. I might have to look it up, but there's going to be different kinds of waves. So in Arduino, we can also create our own functions. Void means that the code will return nothing, and this function will return nothing. So this one will do void square duty. Squares. So this creates a function that is in our computer code, and it returns no value, returns nothing back to the main loop. The main loop is going to call a function. So we'll start with squares. And like I said, our main loop, I like a lot of comments. I like to make my code very clear and easy to understand. So I like a lot of separators, lots of comments, lots of things to make sure that, you know, everything is clean and easy to understand. Sorry, in chat. You got your name, or could I call you my? Oh man, there's only one person I can say yes to right now, I think. I think, are you that person? I don't know. I don't know. Are you that person? I have no idea. Or I don't know. Can I call it? Can you call me yours? I don't know. Maybe. maybe. Depends on who's asking. My name is V. My name is V. For those of you that want to know, V. That's my name. Nice to meet you. A lot of people call me Red Eyes, Dragon bitch. Whatever, you know, I don't care. Drop me. There you go. Maybe. I'm very busy, so, you know, my Insta, everything is RedEyesBadDragon. If people want to know my stuff, they can always find me here. All my links to everything that's in the public domain, which is basically everything I do, can be found at linktree.com/RedEyesBadDragon. Fair warning, I am a trans porn star. That's how I get my needs met. So yeah, fuck them people, say what they're jealous of. Exactly. Oh yeah. Fuck you. Oh yeah. You. Rose, you got no idea. You got no idea. Basically. Yeah. So let's do this. Set up code. Runs once. I like organizing my code with lots of separators, lots of comments. It's just a habit I developed over the years. I always found it easier to look at code on screen if it's nice and evenly separated. I know it doesn't fit typical software engineering convention. Fuck that. I follow my own conventions. I follow my own conventions. Main loop runs indefinitely. I don't know if that's how you spell indefinitely, but you know, I'm too lazy to check. I'm too lazy to check. Too lazy to check, guys. Also, nice pickup line. Also, nice pickup line. Everyone wants to hit on the prof, dude. Okay. This needs something sent into it, and it needs. Does it need something sent to it? No, I don't think so. I think we'll have a decision logic here. We'll do an if. What is a decision logic, people? I want to know. Decision logic is a way for the computer to decide what it's doing. So we'll probably have a few different, if we'll make this standard right now, but you know, we'll add more to it later. This is because we're probably going to have new functions later. Void, oh shit. Yeah, we're gonna have more functions later, but we're gonna start with this. So we'll have one for like void signs, you know, we'll do signs, yeah. We'll do stuff like this. Because we'll want to experiment with different waves running through our electric field transformer. We'll want to experiment with, you know, square waves, triangle waves, you know, pulse waves, resonant pulse waves, you know, just, oh, awesome. Sweet. I'll check it out later, after stream. Thank you for the follow. Namaste. Appreciate it. So yeah, we'll do different kinds of waves and shit. Nice. Nice to meet you. Yeah, we'll do different types of waves and shit. Basically signs, squares, all kinds of shit. And the reason is because we're testing different efficiencies of resonant waves through the circuit. So we're going to start with just squares, and then we'll have a decision logic off of this to decide which wave we are running if we want to do it that way, so we don't have to keep redeploying code. You know. Resonant pulse. Do we have to define functions in Arduino code? I cannot remember. I think we might have to define them. Yeah, so we might also have to define functions. Void squares. And you define functions up here, I think, just like this. Pretty sure. Just so that this might be an unnecessary step. We'll see if we get a compilation error. Like I said, I haven't written code in a few years. So be patient with me if we have some errors as we're going here. We'll comment this stuff out for the time being. We'll uncomment it when the time comes. So yeah. And we'll run squares here. And squares is going to be a variable duty cycle pulse wave. So what do I mean by that? This code here, this pulse wave in our digital write code, this example code here creates a digital pulse wave that has a duty cycle of 50%. Half the time it's on, half the time it's off. To create a variable pulse wave, we just need to alter the the duty cycle. How long is it on? How long is it off? We can affect that by changing the delay between ons and offs. So we will do that. So we're going to write digital writes. Digital write of our carrier wave. And then high. Pin mode, carrier wave, digital. We'll initiate that pin as well to be digital low. I am from Las Vegas currently. The United States. And we'll write that to digital. Does it need to be digital low, or can we just write low? Yeah, we can just write low. And then for our functions, I like doing it a little bit differently. Just so we have some distinguishing separators between our main code and our subsequent code. So yeah, our squares is going to be a digital write, carrier wave, high. And then it's going to be a delay of some value in milliseconds, and then it's going to digital write carrier wave, low, and it's going to be a delay of some amount of time. Our time is going to be the variable t. You should normally not create single letter variables. You normally shouldn't unless they're local variables. What is a local variable? A variable is just a symbol that can be changed. So, let's make this a single int, variable t, and we'll initiate it to 0. Is that the proper? Yeah, I think. I'm trying to think of what's the best way to do this, because there's a flow to the time and speeds of which things run on here, and initiating a local variable for our delay time might not be the most efficient way to do it. I know this is kind of going over the heads of most people that would end up watching this, because it's trying to be very low level shit, but try to keep it simple. So we'll set to 0 for now, but normally it should be a little bit more obvious with what your variables mean. So int t is and you should always comment your variables, kids. You should always comment your variables. Tell people what the variable means. Delay time between on and off square waves in milliseconds. Gotta add units. It's in milliseconds. So we can also create 2 more just in case. So we'll leave these commented out because we're not going to use them now. T0 equals 0. Actually, we'll do it just so the spacing's right, and then we'll comment it out because we want to keep our convention here. Delay time after on signal square wave. So making a variable time is going to be, so a single delay time is only going to ever achieve a variable frequency at 50% duty cycle. But say we want to change the duty cycle, but you know, what do I mean by that? A single delay time, a single t delay, 50% on, 50% off. We can only ever get 50% on and 50% off if we're doing the same time between on and off. In that case, we can only change the frequency of the square wave. Now, changing the duty cycle is how long is it on compared to how long is it off. Is that ratio 50%, 20%, 5%? That's the duty cycle. We need 2 different time variables for that, not just one. So that's why I'm creating these other variables, int t0, int t1. Yes, I'm initiating them all to 0, but you know, the values will change in the future. And this is because we are going to need a little bit, but you know, it's okay. You welcome chat messages whenever. Don't feel stopped by a chat, but you know, I am busy here working on the project. So please don't feel offended if I don't respond. Delay time after off signal for a square wave. Yeah, as long as you're not insulting me, I have no issue with people chatting me. The only time I have issues is if somebody insults me like earlier today, then let's just say I'll be a disrespectful piece of shit back to you and I'll ban you. But no, I just, you know, I don't like dealing with assholes. So, you know, keeping it pretty easy, pretty straightforward. So this will allow us to have a variable duty cycle, and then the ratio of that will change the duty cycle, and then the overall delay time will change the frequency of that variable duty cycled wave. Yeah, so delay t at t seconds, return. So right now this would be 1 second on, 1 second off. Should we make this a loop? We could make this a loop. I think we should. For 1. So what's a for loop? Or let's make it a, yeah, we'll do fors. We'll do fours. For one, a for loop is like our loops up here, our void loop. A for is a kind of loop. Anything inside this bracket here is going to keep running for as long as the condition within this is true. A 1 is saying always. A 0 would be never. So you could add logic while 1 is equal to some variable, like while 1 is equal to t. This is not a true statement because 1 is 1 and t is 1000, but if, you know, this were to, that would be true, so it would always run. So we can get fancy with the logic later. We're just keeping it always on for now because we're just starting simple. We're starting with the base. We gotta build up. We gotta build development prototyping up. This is light years faster than designing a custom LRC circuit to run off of our electric field transformer. This is going to be light years faster as writing code. Designing and building a circuit takes a lot of time and effort. This takes time and effort, but less, and we can be much faster and much more creative. Yeah, please don't be insulted by that, by the way. The interrupting thing, you know. I don't care. People, feel free to message me as much as you want. You can. I can't stop you. Just be respectful. That's all. That's all. Mm-hmm. 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 If I feel satisfied. What does this conversation entail? Keep in mind, dude, I'm a porn star. I literally get hit on for a living, dude. I get hit on for a living. If you're going around Twitch streams trying to find a girlfriend, you came to the wrong streamer, my friend. You came to the wrong streamer. You came to the wrong streamer. I'm not trying to be an asshole, but you know, I gotta be straight up with people. You know, I can't entertain every offer. I physically do not have the time. Physically do not have the time. So maybe, solid maybe. I appreciate the follow on Instagram. You know, I will check my Instagram at some point today, you know. But I can't promise you anything. You know. Yeah, so for one, I think that's good. You know, it's just saying that a square wave will run for as long as forever. Forever. It'll run forever. This is decent code. Yeah, in return. We need some braking condition. We need to add a switch. We need to add a stop switch. So why do we need to add a stop switch? A stop switch can break us out of these loops so we can continue rapidly testing. Let's try compiling this really quick. Compiling, for people that don't understand, is a way to... Yeah, no board slow. Right, compiling is a... We gotta select our board manager. Which board are we using? We're using an Arduino Uno. Rev 3. Oh, there's an R4. God, they made the software so much cleaner since last time I used it, which was like years ago. It's so much cleaner. So nice. So much nicer. Okay. Hopefully that works. Verify. No board selected. Let's tools, ports, COM, Arduino Uno. Gotta select the COM. The COM stands for communication. It's just saying that our Arduino board is connected to COM6. For some reason, our computer assigned the USB port we plugged it into as COM6. Why are you degrading yourself? Come on, you're cute. Maybe give me a little chance. I'm not degrading myself. I'm just, like, I'm fucking gay. Like, you know, romantically, I prefer women. You know, I get hit on for a living, like I said, you know. I'm a porn star. Like I said, you know, I'm not degrading myself. It's actually quite liberating. You know, I'm a trans girl. I'm an alien incarnated as a human, scaly, you know. Please be respectful of that. If you keep asking me about romantic interests, I'm gonna ban you. That's your only warning. Namaste. Namaste. Yeah, anyhow, I'm sorry, I have to be so fucking blunt with people, guys. I don't have time. I don't have time to entertain this stuff. You know, I'm trying to fix a very serious problem. Oil and banking empire. Hello? Yeah. I'm sorry to be a cunt. I'm not trying to be a cunt, you know. I'm really not trying to do it. You know, I just have to be straight up with people, you know. And if you're, like, consider, you know, if you do porn for a living, which I do, you know, you tend to get this kind of thing a lot. It's very flattering. I am flattered, thank you. But, like, I am, and I appreciate it. But, you know, I'm here to build something. I'm not on this stream to date. You're still welcome to send me a message on Instagram. I'm not gonna stop you. But, you know, just be respectful of the stream. Thank you. Oh, yeah, check out my YouTube then. Sorry for the misunderstanding. Sorry for the misunderstanding. Uh-huh. Mm-hmm. It's what happens when you live as a sex worker. You get used to it. Sorry. Yeah, it's what happens. Yeah, we might want to grab a breadboard here. Why are we doing this? Because, we're gonna want to break out of these loops occasionally. We might not do it today, but, we'll at least get it ready. We'll have a little button here. Whenever we press the button, it'll stop the carrier wave. There's a way to stop the resonant wave cycling, so we will use it through that. Yeah. I'm sorry. Like I said, not trying to be a cunt. I always gotta be open and honest with people. I'm never trying to be a cunt. The only time I try to be a cunt is if somebody comes at me and is very disrespectful. Then I'll be a bitch. then I'll be a bitch. No, you seem fine. Yeah, if you want to know about my ideas about humanity and all that shit, it's already public on YouTube. I already gave you my link tree, so have fun with that. Yeah. So yeah, where were we? Yeah, squares, run squares. It's missing fully qualified board name. That's bullshit. No board selected. That's bullshit. There is a board. Oh, my dumb ass. I'm not used to this. Ah, right. Okay. So you need to add some basic libraries. I cannot remember the libraries, so we'll add those in. What are libraries? Libraries, like where the name is derived from. Like how a library holds information for, you know, books and stuff and humanity and shit, you know, for languages, information. Code has libraries of itself. These machines, they need their own libraries. A basic lightning rock computer doesn't have the information that it needs to operate at the base level. It needs some kind of a dictionary, a lot of dictionaries, lots of books, a library to understand some of the instructions. So we got to include those. We got to include libraries. You would do that by include, which is a command. We include libraries, and then we need certain libraries. I think there's, I know there's standard IO. Thing is one. I really can't remember all the libraries Arduino has. That's why I'm looking them up. Maybe it's st.io. I don't know. std.io. I don't know. We need to include libraries, but yeah, let's add a comment here. Get. Okay, yeah, take care. Sorry to be rude. Didn't mean to be rude. Just want to be straightforward. Nice to meet you. Please feel free to come back whenever you'd like. Nice to meet you, Rose. Namaste. Library, and it's, yeah, basically get the base information from the internet, basically. Yeah, basic. I'm trying to think of a good way to comment this. Library is fetch base instructions from internet. Yeah, that's a decent comment. I don't know. Oh, there we go. Yeah. Manage libraries. Let's see all the libraries. I don't know what the input-output library is called. Also, I'm reading the chat while I'm looking up libraries, dude. You said you don't want to be romantic, but you said you're cute. Maybe give me a chance. What is that, dude? How is that not romantic? How is that not romantic? Anyhow, we're leaving it in the past. Not nitpicking. not nitpicking. I read that scenario perfectly fine. Trust me. Oh man. Give me a chance, baby. Let me come over. Let me get in your bed sheets. Give me a chance. I'm sorry. That's just how I read it, dude. It's because it's how it is. That's how it is. Gosh. I cannot remember. Oh man. Computer programming is not like riding a bike. If you don't exercise the muscle, you will lose a lot of the nitty-gritty details. Like, I still remember the general shit. That's like riding a bike, but the nitty-gritty details, they... Oh, if you're not constantly using it, you're not gonna remember it. Oh man, dude. What is the standard input-output library? I do not know. Arduino. Okay, you know what? It's actually probably easier for us to pull up an example code. So let's save this really quick. Let's save this inside of the... Where is the path to our Ouroboros directory? Let's get that open. Yeah, version 0. Let's do this. New folder. Code. And we want this path. So the path to this is properties. So this is the path to this location in our computer. It should end with a slash code though. Select all, copy. That's our path. Where do we want this? We want this and a new path, that path, in progress code. That's where we want to save this. And we're going to save this as our WaveGen version 0. Seems fine to me. It seems fine to me. Yes, I know we're saving code that doesn't compile. It's fine. It's fine. Yeah, so the good thing about Arduino is it does come with examples. So let's open up an example here real quick. And we should see, hopefully, no? You guys don't have libraries either? Maybe you don't need it. Maybe maybe it's already built in. Let's open a different example. Let's open the... Oh man. Let's open that one. Should be a library example here, I hope. No? Really? Guys, come on. Don't be like that. I need an example of how they include libraries. Oh, okay, let's see this. Let's look up defining a function. Maybe that's our error. Yeah, welcome to coding, everyone. It is a very boring process of Googling shit. Arduino define function. Let's look up that. Using... okay, that's using functions. Let's look up that. Yeah, I think we got it fine, honestly. I don't see any issue in our code. So why is our code not compiling? That's the real question. Let's check again. Compilation error includes expects file names over file name. Oh. Here, let's get rid of this. Save that for a second. Check that. Okay. Pre-processing direction carrier wave. Oh, right, because we need to define. My bad. We need to define. Let's try that. Okay. Next error. Oh. That's silly, but it makes sense. We just need to terminate that statement. Primary expression before the... for 1 equal to 1. Let's just do that. Maybe that is... Huh. That's interesting. Let's look at what Arduino's for loop example is. See, this is why Arduino is great, is because they have a bunch of example code just at the damn ready. All right, okay. So for loops need to follow a certain pattern, initialization condition increment. Yeah. So let's instead of using a for, let's use a while. It's probably what we should have used from the start anyway. While one. A while is just an easier way to make a for. A for is saying for this initial value on this condition, increment it this many times. A while loop is saying while this thing is true in here, do this until this thing is not true. So what we really wanted was a while loop. Yeah, that's better. Primary expression before that. What do you mean? Maybe we don't need the return statement since it's a void. That would be correct. We do not need a return statement since it's a void. Alright, so this code compiles. Right now, all this code actually does is it starts a square wave out of our terminal at a 1 Hertz frequency at a 50% duty cycle, which is every second it's on, and then every other second it's off. Every second it's on, every other second it's off. That's what we do. That's what it's doing. Basically, you know, that's it. It's a simple square wave. It just turns on and off. That's all our code is doing now. We will get much more complex with the code as complex as we need to get. Let me rephrase that. This is not going to be very complex code. It's going to be pretty simple code. And it'll be as complex as it needs to be for the following. You know, making sure this stuff works. That's about it. So that would be plugged in. Hopefully it's not running. I don't think it is, but you know, let's also get a grounding wire here. Let's get a ground going. So let's just get a simple way to measure what is going on. So we have an input, we have an output, and yeah. There we go. Tug test is on. So we have our inputs. We have our output. Our output is just going to go to ground. So we're just making a loop onto the board right now. I don't know how much power this can sink. It'll be fine. If we send too much through it, we're just gonna break it. Quite frankly, if we send too much through it, we're just gonna break it. It'll be fine. We can fix it. We gotta break shit to make shit, as they say. So we have an input on our input. We have an input on our input coil, guys. We have an output on our output coil. The input is going to go to our pin number 5, which is running our square wave right now. And our output is going to go to ground. I do not want to ground this yet, because by doing so would complete the circuit and it would begin running. I would like to get our oscilloscope up so we can see exactly what happens as we plug it in. My guess is we're just going to see a normal square wave. My hope is we see a square wave with some distortion or some gain, i.e. voltage gain. That would be a good place to start. But, you know, things take time. Things take time, as I say. That's our code for now. We're just gonna be, we're just gonna delete these, my friend. Yeah, don't even be sly about that shit, dude. Yeah, anyhow. So, we're going to grab our oscilloscope, analog discovery 2. Oh shit. Well, okay. It is that time. It's at 4:05. I didn't look at the clock. Alright, so everyone on stream, if you guys are here watching, if there are people watching, thank you guys for coming today. I know we're about to start measuring this and seeing what our square wave looks like through the electric field transformer. We're going to pick up tomorrow with that. So tomorrow we're going to download waveforms, get it hooked up and tested. I have to end the stream today. If I don't do this, I'm going to start fucking up my schedule. And I cannot do that. We're already 5 minutes over past when I should have ended it. Can't do that. We have to obey the time here. I'm not going to be working on this for more than 3 hours a day, 5 days out of the week. Because, like I said, I stream this, I stream sex work, I edit, upload YouTube stuff, you know, and I do all my social media stuff. I do a lot. It doesn't look like it, it doesn't sound like it, but it takes a lot of time. So, we're going to stop this here today. I am rather happy with the progress we've made. Quick recap, we basically just got the core windings done, ready for testing. We got some basic Arduino code written, ready for testing. It's going to get a little bit more complex, but not that much more complex. We're just going to add different wave functions, different, you know, sorts of things out of this. We're starting small, working our way up. So, overall, day one summary, we added quite a bit. Let's talk about that while we do our GitHub push and commit here, guys. Let's talk about this while we did our GitHub push and commit for the YouTube video. That's going to be uploaded after this. We will upload the raw cut of this. You know, chat problems, disrespect, and all, baby. Yes, we are going to upload this with all the chats from today. the good and the bad. The good and the bad. You know. Yeah. But thank you, Rose. Fuck what other people say. Honestly, if people give you disrespect, as I said earlier, if people go out of their way to give you disrespect, it's just because inside themselves they don't like themselves. That's why they have to project hate outward. It's toxic, but you know, it is what it is. So yeah, here we go. Version 0. GitHub looks like we got all of our code in there. So Ouroboros dev day 1 primary coil winding wound computer occult physics and consciousness physics explained. Began writing Arduino code and wiring up a test circuit for the electric field transformer. Arduino should be capitalized. Tomorrow, on Dev Day 2, Friday, tomorrow we will begin testing the E-field transformer with simple square wave pulses through our Arduino code. We will try and capture the results on our analog discovery 2 oscilloscopes plots. Namaste, everyone that joined our chat. Lesson 3. Yeah, okay, that's about it. Oscilloscope. Yeah, okay, there we go. I think that's good. Let's commit that to main. Alright, so that's going to be updated, upload to main. That code does not work. I probably Can I access my local commit? Oh man, I know how to do this shit on Linux. I don't know how to do it on Windows. I don't know how to do it on Windows. Oh man, where is the commit? I want to change my commit message. I mean, the code works, but, you know, we don't, yeah, it's fine. We'll push it. We'll push it. Okay. We pushed it up. That's it for today, everyone. Yeah, sorry for being cunty a little bit during stream. I know I curse a lot, guys. Sorry. Sorry for being a little bit disrespectful, but, you know, if people bring me disrespect, I hate to say it. I'm gonna be authentic, and then I'm gonna ban you. Authentic is just me having self-respect, basically. But yeah, that's it for today. Off to a good start still. I will see you guys tomorrow when we will maybe make this a little bit nicer, and we will also begin testing things. So I hope you guys are excited. I sure am, and I will see you guys tomorrow for another one. Namaste, everyone.